In this session, we will look at the IoT solution stack. You will find a very close correlation between this session and the session on the IoT value chain. The solution stack will give us a picture of all the different components that make up an IoT solution. To start with, we have the real world objects, be it an airplane, be it a car, be it a building, be it any scenario that needs to be monitored or controlled. In these real world objects, we will have sensors and actuators. Sensors to sense and generate data, actuators to control the objects. The sensors and the actuators will connect to controllers, microcontrollers like Arduino or Raspberry Pi or any in that family. The controller will communicate to the gateway, the IoT gateway or the IoT platform via a wireless connection or through a wired connection using some communication protocol. From the gateway, the data is sent to the cloud and then the analytics, then the mobile and then the social. Thus, if you see, the solution stack has various layers which build one on another to give us the complete IoT solution. The first layer is the real world objects, which will have sensors and actuators. The second layer is of sensors and actuators. Now, what are sensors and actuators? Both are transducers, that is, they convert energy from one form to another. Sensors and actuators convert energy from one form to another. Sensors convert some kind of real world physical energy into electrical signals, whereas actuators convert electrical signals into physical energy. By definition, sensor is the device that detects and responds to some sort of an input from the physical environment. That input could be light, heat, motion, moisture, pressure, or any of the other environmental factors. The output is generally a signal that is converted into a human readable display at the sensor location, or it is transmitted electronically over a network for further processing. The actuator is the exact opposite of a sensor. It converts a signal, usually the electrical signal, to some action, usually a mechanical or a physical action like motion or force. This is what we define by sensors and actuators. There are so many kinds of sensors available in the market for you to build your solution. Different sensors sense different things. Let me list a few. Proximity sensor, which is generally present in your mobile phones, will detect if you are close to that particular object or the sensor. The motion sensor will detect if there is motion happening around the sensor. The temperature sensor will detect the temperature around the sensor. Similarly, the humidity or the moisture sensor will detect the moisture content around the sensor. Acoustic or sound sensors determine the frequency of vibration that is emitted. Chemical or gas sensors detect a particular gas around it. Flow sensors can determine the speed of flow of a liquid through the sensor. Similarly, you have different kinds of sensors like force sensor, pressure sensors, leaks sensor, electric and magnetic sensors that can sense magnetic fields or electric fields around it, acceleration sensors, those that are used in your phone games to detect the tilt and the speed of the tilt. Or you could have light sensors to detect the light in a particular room around the sensor. Thus, the sensors are available in all different kinds. Each sensor comes with its own unique ability to sense something around it. And if you want to find more about the sensor, you have to seek out the data sheet that comes with the sensor, which gives you the exact information on the capabilities of the sensor. The third layer is that of controllers, or also called microcontrollers or boards. Boards and microcontrollers come from different vendors and they integrate or interface with the sensors and actuators. They are generally low priced. It's easy to read or write from these boards using input and output pins. In short, the functionality of these controllers or microcontrollers is straight interface with sensors and actuators. The most common microcontroller used by beginners in IoT is the Arduino. And the Arduino Uno is the most common board within the Arduino family that is used. The question is, why is Arduino so popular with IoT beginners? One of the most prominent reasons is that it is inexpensive. It will cost you anywhere between $10 to $20 depending upon which part of the world are you living in. It is very simple and easy to work with. The best part, its executable file runs on any operating system, whether you have a Windows machine, whether Mac or Linux. It has a very simple and clear programming environment. On top of it, it is based on open source and can extend itself to multiple types of hardware. The reason Arduino is popular is because it is very easy to use for beginners, yet for advanced users it is flexible and extensible. Hence, it is used by thousands and tens of thousands of people in different projects and applications. The Arduino has the capacity to integrate with multiple sensors and actuators as shown in this diagram. So whether it is the accelerometer or the infrared sensor or the ultrasonic sensor, LEDs, force sensors, LCD displays, USB ports, relay buttons, servo motors, potentiometers, different sensors, actuators, hardware can be extended to the Arduino board, as a result of which Arduino has become the first choice of microcontroller for people working in Internet of Things. Along with the Arduino, the next most popular board is the Raspberry Pi. It is also known as a single board computer or an SoC, that is a system on chip. It is called a single board computer because within a small real estate of a chip, it has the capacity and the power of a mini computer. The Raspberry Pi is also known as a system on chip or an SoC, which means that there is a complex integrated circuit, that is an IC, that integrates the major functional elements of a computer onto a single chip or a chipset. As you can see from the diagram, the Raspberry Pi has a programmable processor. It has an on-chip memory. Through the general purpose unit, you can accelerate the hardware functionality. It is compatible with hardware and software. There are different ports and slots: the HDMI, the USB, the SD slot, the audio, video, the Ethernet slot, the camera. These are all the capacities of the computer that are brought onto a single board, the Raspberry Pi. The benefits of Raspberry Pi are very straightforward. Because everything is compact, it reduces the overall system cost. So in the cost of a board generally costing around $60-70, you get the power of a mini computer. Because of its capacity to accelerate the hardware functionality, there is increased performance from the Raspberry Pi. And since its size is very small, its power consumption is also on the lower side. And on top of it, the small size of the Raspberry Pi is its biggest advantage. There are many people, once they graduate from the Arduino, Raspberry Pi is the board of choice for such designers. It is even used in industrial applications because of its benefits. Thus, the Arduino and the Raspberry Pi are the two most common microcontrollers or boards used to interface with the sensors and the actuators while designing IoT solutions. The fourth layer is the communication and the protocol layer. The controllers need to speak to the gateways through some specific protocol. Now the question is, how do you know which is the right protocol for the data that you are carrying? There are certain factors on which you can choose the right protocol. To be precise, there are three factors. The first factor is the data rate of communication. The second factor is the range of communication. And the third factor is the power consumption that will take place through the communication. Based on these three factors, you can choose the right protocol for data carrying. In this fundamental course on Internet of Things, we will not be studying the protocols in depth. In our next course, which is the intermediate course in Internet of Things, we'll really be studying a lot of these protocols in depth and which protocols are used under what scenario. All that will be covered in the intermediate course on Internet of Things. As you can see in this figure, the area marked 1 is the low data rate and the low range communication. There are many protocols competing in this region. The Z-Wave versus Zigbee are the prime protocols used for low rate and low range. One of the critical factors about this region is that the interoperability is missing between the protocols, as a result of which there is consortia wars that are emerging for the low range and the low data rate communication. Is generally with the home appliances that you see this kind of protocol usage. The area marked 2 is the low data rate but the high range of communication. Here you have the Sigfox or the LTE CAT or the 802.11 communication protocols. However, the protocols in these regions are in very early stages and are competing directly with each other. For high data rates, the preferred communication protocols are Wi-Fi and 4G LTE. but these protocols also have very high power consumption rates. Thus, depending upon your application and the data that is generated by the application, would it be traveling far? What would be the rate at which data is generated? What will be the power consumption if you use certain protocol? You will have to use all these parameters to finalize the right protocol to use in your application. As of today, the most common IoT protocols are Bluetooth, Wi-Fi, COAP, that is Constrained Application Protocol, MQTT, Message Queue Telemetry Transport, XMPP, Extensible Messaging and Presence Protocol, 6LoWPAN, that is Low Power Wireless Personal Area Networks, ZigBee, Z-Wave, Sigfox, LoRaWAN, LTE-CAT, OnRamp, and so on. Make sure when you're designing your IoT solution, you make use of the right protocol for your communication of data. The fifth layer of the IoT solution stack is the layer of data aggregators, known as IoT gateways, and in further applications, IoT platforms. Now, what are gateways and why do we need gateways? There are so many sensors, devices, controllers, and the data needs to go to the cloud. The cloud cannot be talking to each individual sensor or each individual controller. You need to aggregate all of this data before sending it to the cloud. That role is performed by the gateway. The gateway does few important things in an IoT solution. First, as pointed out, the gateways collect and aggregate the device data as well as manage the device at the gateway. The gateways also provide interoperability between the edge devices, especially if they are speaking the same protocol language. To maintain a secure and robust connection between the devices and the cloud, there is an extra layer of security that is applied on the gateways. So the gateways ensure that the data being sent to the cloud is secure. These are the three important functions of the gateway in an IoT solution. However, the challenge comes when two devices who speak different protocols are connected to a gateway and they want to talk to each other. This remains a constant challenge for the gateways. We will discuss what are IoT platforms separately in the next session. The sixth layer is the SMAC stack, and we have studied the SMAC stack extensively at the start of this course. The SMAC stack provides the intelligence to the data that is collected from the sensors through the controllers, passed through the gateway, and from the gateway it comes to the cloud. The SMAC stack gives powerful insights from the data that is collected. Thus, using the 6 layers, you can build an IoT solution.